This is the second video of 4.1 Algebra 1 Notes, covering examples 5 and 6. So, when they ask you to write a linear model, a linear model sounds fancy, but honestly, it is just a linear function that goes with a real-life situation. So, it's an equation of a line that we write that goes with a word problem. That's really what it is. So, it will talk about a quantity changing at a constant rate. And so if it's a constant rate, that means it has a constant rate of change. So the value of m is the rate of change, which means slope. And then b is the y-intercept. Also sometimes the initial value or starting value of y. So like where the story problem begins. For example, if you're talking about like population and it started with 50 mice in a population, then we'd start with 50 and then we find out how much they grow per year. Okay, so let's try this. So this says, excluding hydroelectric and solar, renewable energy sources in the U.S. generated 143.4 million megawatt hours of electricity in 2009. So this number, 143.4, is how much electricity was produced in 2009. Okay, it says this quantity increased at an approximately constant rate. So that tells you, if it says it increased at a constant rate, this is what tells us it is linear. And then it says it reached 333 million megawatt hours by 2017. So that 333 is how much electricity was produced in 2017. Okay, it says estimate the amount of electricity generated from these sources in 2021. So the first thing we're going to do is you are going to let x equal, we started in 2009, so x is going to be the number of years since 2009. So in 2009, that was 0 years, and it was 143.4 million megawatt hours. So I'm going to write that as a point. So 0 represents 2009. Okay, think about 2017. How many years after 2009 is 2017? Okay, it is 8 years after. So 8 years since 2009 is 2017, and the electricity was 333 million megawatt hours. Now remember that we learned in the beginning of chapter 3 that the independent variable, if there's something about time, in this case years, then independent is always time. So that's why the years went in the x spot and the electricity went in the y spot, is because of that. So now we know it's a linear model, so we can find our slope. So we're going to do 333 minus 143.4 over 8 minus 0. All right, so 333 minus 143.4 is 189.6, and 8 minus 0 is 8. And when you divide them, I get 23.7. All right, so that's my slope. And I know that my y-intercept is this one right here that had 0. It was when it started, because your y-intercept is your initial value. So when we started tracking the electricity, that was in 2009, and the y-intercept was 143.4. Okay, so keep in mind that x is the number of years after 2009, and the y value, or f of x, is the amount of electricity. So if we are wanting to generate 2021, right, then that would be x equals 12. We would plug in 12 years to get to 2021. So we would do 23.7 times 12 plus 143.4. And we would do that in a calculator. Okay, so we take 23.7 times 12 plus 143.4, and I get 427.8. So what that means is in 2021, right, the US should generate 427.8 million megawatt hours of renewable energy. Technically renewable energy excluding hydroelectric and solar, so from other sources, but we've kind of got it right there. Okay. So example 6 says the profits of Company A and Company B X years since 2016. So X represents the number of years since 2016 has happened. Can be modeled by this function, f of x is ax plus b. That's in the format mx plus b. So they're just indicating it can be modeled by a linear function. And g of x is Company B. Once again, it looks like it's a linear function. That's what they're telling us there. So it says compare the values of b and d, explain your reasoning. B is the y-intercept or the initial value of Company A. D is the y-intercept or the initial value of Company B. So the initial value of Company A is the blue bar, and you can see it right here. In 2016, the blue bar is at 2. So the B value would be 2 because the company profits in 2016 were $2 million. That's what Company A started at. And then the D is the starting value in 2016 of Company B, which is the red bar, and that's at 1.5. Okay, so what this means is Company A started with $2 million of profit compared to $1.5 million of profit for Company B. So Company A started with $500,000 more in profit. I wrote that wrong, sorry. $0.5 million more in profit in 2016. That's when we started tracking this. So the starting part is in 2016. Okay, so initially the blue company, Company A, was the one that had more profit by $500,000 more at that time. Okay, now it says compare the values of A and C. So A is the slope of the blue company, Company A. So look at Company A. All right, in 2016, the blue bar was at 2. And 2017, look how high the blue bar is. Okay, keep in mind this is going by halves. This is 2.5. So the blue bar is at 2.25. In 2018, look how high the blue bar is. It's at 2.5. 2019, how high it is, it's at 2.75. So you can see what's happening here is it's going up by 0.25. So A is 0.25, which what that means is Company A grows in profit by $0.25 million each year. They're going up by 2.5 or $0.25 million each year. They're increasing their profits. Okay, now look at Company B, the red ones. So look at that. We've got 2016. We'll just kind of compare like we did the other one. So we look at the red bars. We look how tall they are. In 2016, it was at 1.5. 2017, it's at 2. 2018, it's at 2.5. 2019, we're at 3, and so on. So that value, what the slope is, what it's growing by, it's clearly growing by 0.5s. So that is the C value. C is the slope for company B. So the C value is 0.5. So what that tells us is company B grows in profit, like they have higher profit, by $500,000 each year. And so that means when we compare them, that company B is growing their profit, is increasing their profit twice as fast as company A. Because when we compare them, we don't just want to write about them like separately. We want to compare them to each other when it says compare. So company B increases profits twice as fast, because 0.5 is twice as fast as 0.25. So when you compare, talk about the first company, the second company, and then actually compare them. Who's faster, how much faster, that kind of a thing.